Who are we? Who is Esken? Yeah, we were founded in 1999 as a university spin-off, always really focused on innovations, on research and development with our instruments, etc. Because our founder was from Boco University, Vienna, and he was a scientist in some kind of way. Now we are owned by Badger Meter. From US, you know it. They are more into flow metering, but we still have our entity, our headquarters in Vienna. We will also keep it, I think. Yeah, this is just an addition. In addition, they take the water quality because it makes sense. They have quantity and now they have quality too. We have 4 subsidiaries in US, Mexico, Spain, and France, and then the project office, which also I'm leading the India office. Then we have in China an office and also in Italy and Portugal. We have 45 sales guys globally, an R&D unit, and here are the numbers, but they are changing, they are growing even. We have, I think at the moment, we have 80 people, not 75 anymore in globally, and even 12 of them are only R&D. So if you see that ratio, we are really investing a lot into research and development. Also, I'm working close with the group. We are, on the one hand, we are producing sensors, terminals, software for online water quality monitoring and event detection. Even like a classical case, I think, especially in environmental monitoring, is if you go to event detection, okay, you see the event, and then you want to prove the event. So with our terminals, you can you have the online sensor giving you an event, and let's say a threshold event on a certain level of a parameter, and then you can trigger an automatic sampler directly, and you can bring it to the laboratory and prove that there was really an event. Yeah, we are also really much into customer services. We are developing parameters. Even developed last year for, I don't know if you're facing problems with that in your region, but chromium in groundwater from all the textile industries is a big problem in northern Italy, and I developed just a parameter for them based on UVB spectrometry, our core product. Yes, and Mary already mentioned we are the global leader in this online spectrometry with more than 10,000 systems. I really don't know the number yet. It's really more than 10,000 systems sold worldwide. But we have also the whole range. So we are also covering the classical parameters like pH and everything. Yeah, and we are dealing with each. We make it in 4 steps. We have the environmental monitoring, the industrial monitoring, wastewater monitoring, and drinking water monitoring. And I think all of them make really at least 20 to 30% of our revenue. So we are really widespread in the water area. We have a global sales partner network all over the world. Yeah, and also in India, the Ganges project, we are running with our partner there because we need also the manpower there from our partners, because alone we cannot do that. Just for the product range, you see on the left side, we have the spectrometers, which are our core products, which are the which Esken invented in some kind of way at the end of the 90s. And then we are covering also other sensors, like this is a chlorine sensor. Then we have our terminals. Then we have our pipe scan, which is measuring directly the water quality in pressured pipes to avoid water loss in big water networks. We have our monitoring stations and also some accessories for cleaning and everything. Sorry. Yeah, there are sensors or probes. So with spectrometry, you cannot measure everything. We have also these ISE sensors, which are especially in wastewater and also in the environmental water quite interesting, because with these ISE sensors, you can monitor nitrogen loads, like ammonia loads, which are essential for microbiological growth in the rivers. The electrochemical sensors, classical pH, also important, because you see in the environmental monitoring, the combination of ammonia and pH is always critical, yeah, because if the pH rises in the environment just because of the algae growth, it hires the oxygen level. Yeah, nice, but the pH also rises. And if you then get like untreated wastewater into the river, it will be transferred from ammonium to ammonia, and this is fish toxic. I think I don't have to explain it more in detail. Good. This is our parameter range. I can also share this at the end of the presentation with you, but I don't want to go into detail. The only thing you see here, that the first thing here, the spectrolyzer, it's just a multi-parameter sensor which can really measure a lot on organic parameters, on turbidity, and even also it's really precise in nitrogen and nitrite measurement, ammonia not, but we can cover with one device a lot of parameters here. But coming now to the Ganges River, this is, let's say, my baby in some kind of way. When I started at Esken, I was just, we say in Austria, I was thrown in the cold water. No, but I think 3 weeks after joining Esken, I was spent already 2 weeks in India with just handling with the CPCB, the Central Pollution Control Board there, with our cooperation partner, which is also a really important sales distributor for us. And we set up the project there, yeah. And so I just make a quick overview. I don't know if everybody has seen the webinar series, but I just mention here, we build up 36 river monitoring stations over 2,500 kilometers in 8 months. So this was also a big challenge, because you have to have teams everywhere. When you see the map of the Ganges and the map of the stations there, not only in the Ganges, also in tributaries, the stations are built. Even in Kolkata, we have it, and in Patna, we have these stations in sewers that we see directly the pollution load going into the Ganges River. Yeah, and the station spots we had not choose. This was part of the contract. This was chosen by the Central Pollution Control Board, and we established there a data supply system. And this is also a data supply contract. Yeah, this means the stations are on our own property, which means from a company perspective, it's not the easiest thing, because you go in a lead, produce all these stations, they are in our property without earning any money, but we are sending data to the environmental ministry every single hour a day for 5 years now. We started in March 2017, and the original project phase was over in March 2022. 5 years contract. Every hour we sent the data, and this was like in former days, you paid something for an SMS, yeah, like 10 cents or something. They pay 8 cents or what, I don't know the exact value yet. It's like for an oxygen value, yeah, that's it. And this was the concept behind it. And we also maintaining the stations. We have now a data consultant sitting in between the environment, the CPCB, the Central Pollution Control Board, and us, just validating the data and giving us feedback. Yeah, an independent consultant. This was chosen by the World Bank also to avoid, let's say, troubles between the data service provider and the client. Yes, we are now in a transition period, and we are just in negotiations. Next week, we will, I think now it's going fast. They want to plan to extend the project. Yeah, why? It makes also sense because they have other monitoring stations, and they make the network denser and denser and denser, which means then you get a more overview, and it doesn't make sense now to dismantle these stations and measure somewhere else. It makes only sense to make more stations there and see the impact. What I know is that the Ganges River is just for your imagination, the Ganges River is by discharge the 3rd largest river in the world. The whole river catchment, the spider web of the river, makes 25% of India landmass. And in this area, 8% of the world population is living. So it's important. Let's call it like this. Yeah.
Uh-huh.
They wanted to see the status quo of the river, of the tributaries, etc. Then this monitoring project, this is just the mission cleaning Ganga. It's under the mission cleaning Ganga, and this monitoring is just a small part of it. Yeah, they just want to set up the status quo, see where there are impacts, really heavy impacts. Then in the next phase, what I don't know because I'm not a planner or something, or building up wastewater treatment plants, but that the meaning behind is usually you set up then wastewater treatment plants and keep the station running to prove that the wastewater treatment plant is working right. This, I think, was the original meaning. And I think also World Bank, especially in this contract, as we have now this data consultant in between the environmental ministry and us, or the Central Pollution Control Board, I think the World Bank learned a lot from investments in India, that there must be something independent in between, that you know, sometimes there is something going on in the background and they just want to avoid that. That's the point. But yeah, to be honest, but at the moment, I can ask them in future. I was not traveling to India for 2 years now, more than 2 years. And such discussions, what World Bank is planning, I will not get over email. So I just have to talk to the environmental ministry, but they are really cooperative. So it's working quite well there. The only thing what you have to know from a point of project management, if you're doing it there, it's always what we learned, it always takes longer than expected, but yeah, that's it. Okay. For the real-time monitoring of the Ganges, yeah, the maximum pollution loads we usually have in the tributaries, because these tributaries are, you know, these are really small rivers, and there is just a whole household pollution going into the rivers, even industrial pollution. These rivers are dead. They are dead sometimes. Really, there is no anaerobic biological growth. But if you know the situation in such rivers, I don't know. We have some friends of India here. I was even in Bangalore and saw the lake there, and because we worked with a cooperation partner in Bangalore, and when I went there, he told me, Lukas, you cannot imagine, yesterday our lake burned. Yes, this was true, because it was so anaerobic that it produced so much methane that it's suddenly burned. Yeah, a lake. This is not what we call a river or a lake anymore. It's just an open sewer in some kind of way. Yeah, and there we find the most pollution. To be honest, with online monitoring at the moment, we cannot, and nobody can do it, measure the real slow, low concentrations, but impacting concentration on heavy metals, which are also found in the sediment of the rivers and everything. And in the Ganges River, if such a tributary comes into the Ganges River, it has so much water that it's just diluting there. Yeah. But the heavy metals you cannot catch. You can catch some organics, whatever. There are definitely changes between monsoon times and dry seasons and everything. But I think it's also more important from my personal view and from a water quality point of view, it's even more important to monitor the open sewers going into the river than directly into the river, to be honest. This is my point of view from 15 years experience. Yeah. We have our spectrometer, which is the multi-parameter sensor for COD, DOC, TOC, nitrate, TSS, all these organics, nitrogen parameters and solids. It's measured with the spectrometer sensors. Then we have ISE probes for chloride, fluoride, ammonia. This can only be measured with ISE and pH, of course. And then we have our physical sensors, also like for conductivity and for dissolved oxygen, yeah, which are the classical and very important parameters. Also for the CBCB, because they were quite clever. There was in the ranking of, there's a ranking on the most important parameters, and they are group ranked from A to group D. And in the A class, there are mainly the classical parameters. Why? Because they can compare to historic values they have. Because with all the new parameters we are bringing in, they have no reference. Yeah, but now they can compare also from like 20 years measurement before in some kind of. So these parameters are measured up to 17. I will not go through in detail. I will just share the presentation afterwards. Yeah, but up to 17 parameters we are measuring there. You can also see, I think you see my mouse here. If all these are measured with the spectrometry, and then we have a few ion selective sensors. For everybody who is interested, I can share that afterwards, and we can discuss it. We are measuring there, every station is measuring in a 50 minutes interval. We have to measure, we have to send the data in 1 hourly basis, but we measure in 50 minutes. That's why we are doing that just for our own convenience, because we're sending the stations to save energy. They are running on autarkic energy. We do not trust any energy supply anywhere there. It can be, even if you have like permanent energy, that means that in the night it can be switched off. So we are running totally autarkic on batteries and solar panel. And for that we are sending our sensors and our terminals into sleep mode, that we do not spend too much energy in between. And to have the chance to get just to connect to the terminal quite fast, we are measuring in 50 minutes. So every 50 minutes I can connect to any station, even from Europe, over a VPN protocol. And I even can handle the stations from here and guide the Indian engineers if they need something. The file transfer is then an automatic transfer directly to the environmental ministry server. They are really simple. Now you see how this station looks like. You have our terminal. This is just for the level sensor event box, not interesting. We have an external modem, because we have a modem also implemented there, but the external modem can use 2 providers. And we see that in rural areas we had a problem with the signal strength, or we get lost, or some provider just switched off the carrier or whatever. And so this switches between 2 different providers depending on the signal strength. This is just a solar charger battery, and here you see the solar panel. That's it. Quite simple, but robust. Yeah, that's the most important thing if you go in such rural areas and everything. And we also, of course, we had some problems with vandalism, to be honest, but you can imagine. Yeah, I think that's everywhere the same. The most important thing is, the only thing they stole was the battery. Because they saw the solar panel and saw there is a battery inside, and the battery they could use, but the many I don't know, 3,000 euro terminal they didn't steal. Yeah, that's not important for them. Yeah. So we built up, and especially for the Ganges project, we designed with our cooperation partner like a sensor cage where we mantle our sensors inside. This is all locally produced by in India directly, because it makes no sense to send that somewhere all over the world. So except our ESCAN equipment, everything was produced in India. I even worked there with the workshops and all the subcontractors of our cooperation partner. It must be okay, it must be robust, it must be easy to handle, and it must be reliable. And at the end, in the beginning, I had some doubts about it, but in the end, it worked really good out, this kind of. In the Ganges project, we wanted to build up a unique infrastructure. And then I was there 3 weeks in a row, going with just coordinates to the station points. And then I said, no, there is no unique design. It's not possible. It's simply not possible. We have to adapt us to the situation at site. And so we had here you see, we have now 3 different types. We have the fixed stations. This is just, you have the cabinet, the solar panel, then you have an outer cage, which is covering this inner cage you see before. Yeah, it's just, You slide the sensors with the inner cage here, so double protected. Yeah, usually in this case not, but usually we have it at the back side of the bridge pillar, because then you're just in the shadow of the water. And this is only if you have infrastructure, but we have also sometimes no infrastructure. But here we had to profile the station, so we rented boats which are profiling the Ganges River. They are just in minutes interval measuring, and the boat is just going across 4 hours a day, yeah, measuring the river. And the fixed stations where we had no chance, this bridge in the background is just, it's a military bridge, a floating bridge. It's just there like 5 or 6 months a year. Then it's just returned because the monsoon is coming. And so we built such floating devices there, also locally sourced in India. You can even work on them. So I worked even with 2 engineers on one of these floating stations, but you have to be careful where you step. But, but it works out. So you have to adapt in some kind of way if you do such a project. About the file system, yeah, every station is sending over the internet directly to the server of the CBCP. The data handling is managed then on the, we call it the service provider server. So we have a server in CBCP and CBCP has a server. They are really physically separated. This is part of the contract. Don't ask me why. And they are sending the data just from our server to their server. And we are even, we have here an interesting system. The data comes over the internet. It's now SFTP, not FTP, so it's secure. There is a file parser making all the building all the files from the single stations together, make it easier for the CBCP to handle all this data. And the file generator then delivers the data directly to the CBCP server. And on the CBCP server, there is now from our consultant also a visualization tool for our data running. So it's quite simple in this kind of way. This is just about the file structure, but maybe not so important for you, yeah? So this is how, in general, the Ganges project works. What you see here, this was me, I think in 2016 or 17, when I was training there, the Axis engineers from our cooperation partner. I went there, even we split it, we make really an arrangement of teams, because if you have one team which should cover in India 2,500 kilometers of monitoring stations, that does not work. So we had like teams coordinated, at least 4 teams all over the Ganges River, that they have quite low reaction times to get to the station if there is something going on, troubleshooting, whatever. And so I was flying all over the Ganges and training the teams there. And unfortunately, I had no chance now, because I think in October I will go there again and train the new guys which joined, because 2 years ago I was there for the last time, and then I will train on continuously basis how to handle the field equipment. This is also very important, what I learned from during the project phase, also to get like some kind of trust from the Central Pollution Control Board, that they are aware what they are doing there and why they are measuring it. These are scientists, and they're coming then and asking the engineers why the COD that cannot be that and that and whatever. So I trained them on parameters to get a knowledge what the parameter is, that they can really communicate in a meaningful way with the Central Pollution Control Board. Yes, so thank you.